Last talk of the night. That means I can run totally over, right? I don't have to stick to anything. Okay.
One more after you.
Oh, okay. Kevin's already bringing me down. Here we go. KARNAUGH. What is this KARNAUGH? First of all, it's somebody's last name. That's not the important part. But as we all know, math is hard, and Boolean algebra is super tedious. And it turns out there's a better way. What is a rectangle? That's the first question you thought I'd be asking tonight, isn't it? So we can use Boolean expressions to talk about lots of different things, even something as simple as a rectangle. Here are 4 questions that you could ask about any shape and help you decide if, in fact, it is a rectangle. So we have 4 questions. They have 2 answers each. Boy, that sounds like a Boolean. That means 2 to the 4 is 16. We've got 16 possible answers. We add a column here to keep track of for which set of those combination of 4 items is in fact a rectangle, and you can see there are 2 there at the bottom. Turns out they all need to be true, except for that equal sides thing, because, you know, squares are squares, but they're also rectangles. So why am I talking about this? We can use Boolean, like I said, Boolean expressions to talk about lots of things. Let's say we're writing an issue tracker, and each issue has a series of flags that describe different traits of that particular issue. We can use those 4 different flags to build larger states. And let's start with 2 of those, resolved and unresolved. And now if I was going to write a little SQL query to figure out if these were going to, which issues in the database were in fact resolved or unresolved, I'd need to combine those 4 issues in some way. If something is both reviewed and approved, that means it's resolved. If it's reviewed or approved and anyway, any of the other ones, it's not. But what if it's canceled? Wait, if it's deleted, that doesn't make any sense. Hold on. Let's try and write that in SQL. We'll figure this out. So we need a select, and then we need our where, and then we say not approved and not reviewed. Oh wait. There's that deleted thing again. And now there's that canceled thing again. My head's starting to hurt. All right, let's try a table. I like tables. So we get our 4 tables. We have 4 possibilities. They each have 2 options. Boy, that looks familiar. And we add a column to keep track of whether something's unresolved or not. We end up with our 16 possibilities like before. And then we carefully fill in the ones that just tell us if something's unresolved. So let's look at that first row. None of the things are true. That means it's not reviewed and it's not approved, so it's unresolved. And the next one, same thing. It's not both reviewed and approved, so that means it's unresolved. And the next one, same deal. And then finally, it's both reviewed and approved, so that means it obviously has been resolved. So we give it our first 0. Oh wait, there's 4 columns. We've only been looking at 2 of them. All right, so let's look at those deleted and canceled again. I keep forgetting about those. The next 4 are all if it's been canceled, so we know those aren't unresolved. You can't be unresolved and canceled. That doesn't make any sense. And then the next 8 are all unresolved because they've been deleted. You can't be deleted and unresolved at the same time. So that fills in our table. All right. Now, let's see if we can take the 3 states that actually are something we're interested in and turn that back into SQL. So if it's not deleted, not canceled, not reviewed, all right, that's too many words. We gotta come up with something else. There's gotta be, somewhere in the land of computer science, a magical box that you can take word salad and you stuff it in there and out pops something we can use. Hey, look, a magical box. And it comes from the land of KARNAUGH. Let's go back to our table. We'll grab our first 3 lines, but first let's take those titles and let's make them something simple. Nice single letter A, B, C, D. Okay, then we'll go back to our map. And now it's like playing a game of Battleship. Our first item that was true was 0000, so instead of saying G5, you sunk my battleship, we plug a 1 into that first square. And then the next one was 0001, and then 0010, and now we've got all 3 of our 1s in our magic box. And you can pretend we fill the rest of them in with zeros. That's kind of a matter of taste with these things. And then we find groups of ones like that one. We can put those two ones together. But are there any other groups? We try and make the groups as big as we can. So we could circle that last one by itself, but as all good gamers know, the world is not flat. It's actually a toroid, so that means you can go off this end and you come back in over here. It's that or an episode of Scooby-Doo, I don't know which. So our next group actually wraps around from the left side all the way over to the right side, and we get another group of two. And it's okay to have groups that overlap. That's one of the rules. But groups must be the size of a power of 2. So we have 1, 2, 4, 8. You got it. Okay. Now we take those groups. We'll start with our greenish group, and we'll take out just the 2 entries that were in that group. And then we'll look at those columns, and you'll notice the first 3 don't change from the top line to the bottom line. So A, B, and C all stay the same throughout the only thing. Only D changes. And then, so we write the ones that don't change at the bottom, and if they happen to be zeros, then we give them a little hat. Okay. Then we do that with the other one, and in this case, it's A, B, and D that didn't change. C changed, and again, they're all 0, so we give them the little hat. And we pull those out, and now we have our answer, believe it or not. We turn those back into their original word salad, and then one more transition, yay. We put them in here, and we add some connecting logic. Those are ands, sorry, those are so tiny. And then we put an or between the 2 ands, and that is your SQL query. Believe it or not, if you take that and you go back to your where clause and you say not deleted, not dot, 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 and or, not, you're going to get just those 3 items and absolutely nothing else. And that is the shortest possible way to write that particular Boolean expression. It's math, so it must be right. Now, this was a very simple example. It wasn't all that exciting, but you can see in a larger KARNAUGH map, if there were more than 3 things that were making it true, you're going to get more groups and do more things. And the bigger the groups, the shorter the number of terms are in each one of those terms. In our case, we had 3 terms in both lines. The bigger they are, the one less term in each of those. So the bigger boxes you get, the simpler your answer is going to be, which makes sense. More things are true, then it takes less things to make them true. And that is how you use KARNAUGH maps to write crazy SQL queries.